Hello, my name is Muhammad Bezikipli from section 02 of Digital Logic Design, and today I'll be discussing the midterm project that was given to us. So without further ado, let's get right into the contents of this video. So first of all, we will have to look at the question, and we will answer all the things that the question asks us to do. So the things that the question asks us are the truth table and the time diagram. Next is the midterm and the maxterm. Then the K-map and logic circuit. Then we will need to construct the circuit using the universal gate. And last but not least is the simulation to show the functionality of the circuit. So let's get right into the question. So this is the question. I will not be showing a lot. You can pause the video to read the question. So I will move on now. So first of all, we will need to construct a truth table regarding the question. So there are 4 inputs, A, B, C, and D, and 1 output, which is, I name it as F. So these are the truth table. Notice that the output is left as blank because we will discuss on what are the outputs that we will get. So if you read the question, it said that the alarm will only ring when with the combination of A1 and B0, or A0 and D0, or C1 and D0. So with this combination, we will take a look at the truth table, and if the combination of inputs have the any of the 3 following combination, the output will be 1. So if we do it correctly, we will get the output as below. So this is the output. As you can see, for the first inputs A0, B0, C0, and D0, you will notice that it fulfills the second criteria, which is A0 and D0. So the output will be 1. And for the other inputs, you can check it by yourself, and this is the output. So moving on, we will have to draw the timing diagram. So what is a timing diagram? Timing diagram is a diagram that shows the inputs and the outputs of 1 and 0. So as you can see, for the all the A, B, C, D and output F, there are when the line is at the bottom and when the line is at the top. So when the line is at the bottom, is actually 0, and when it goes up, it is 1. So we are referencing to the truth table, and this is the timing diagram that we get. As you can see, for the A, for the first half, it is always 0, and for the second half, it will always be 1. So that's why it starts at 0 until the midpoint, it goes up 1, and until the end. And the cycle repeats for B. As you can see, 0, 0, 0, 0, 0, 0, 0, 0, then 1, 1, 1, 1, and etc. and so on. And the thing that we should take note is the output actually. So for the output, this is the output. F starts with 1, 0, 1, 0, 1, 0, 1, 0, and then 1s, and then for the rest of the output. So this is the truth table field and the timing diagram generated from the truth table. Next, we will be discussing the midterm and maxterm. So what is actually midterm and maxterm? Midterm and maxterm is the other way to write the output of the logic circuit that we got. So as you can see, there are 16 inputs of A, B, C, D, and also the corresponding midterm and the midterm notation. For the midterm notation, the is written as lowercase m with the number. So for the first input will be M0, and the second is M1, and increase until the final input, which is for the final midterm, which is M15. So we will also have the output, which we take from the truth table. So it's the same as the truth table previously. And one thing to note is actually the midterm. So how do we write the midterm actually? The midterm starts off as A naught times B naught times C naught times D naught. So the midterm is written in product. So A product of B, product of C, and product of D. They are times together. So when the input is 0, there is a bar above them, or we can call them as A bar or A naught. So as you can see, when the input is 0, 0, 0, 0, every term A, B, C, and D have a bar on top of their head. So it becomes A naught, B naught, C naught, and D naught. And when the input is 1, as you can see, when the D is 1, the D will not have the bar above it. So for the input 0, 0, 0, 1, the midterm will be A naught, B naught, C naught, and D. And this goes on up until the final midterm. So what should we do with this information? So in order for us to write the midterm, we will take a look at the output. So for midterm, we will only take the output which is labeled as 1. So there are around 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9 outputs which is 1. So we will take all the outputs of 1 and group them together as midterm. So how do we write it? We will write it as below. So this is how we write it. Notice that this is the symbol for the summation. So midterm is actually the written as SOP, which is sum of product. Notice that the midterm is all product, and what can we do with the midterm is that we add them all together of the output of 1. So the output 1 is from M0, M2, M4, M6, and so on and so forth. So this is how you write the midterm. It's summation of M0, 2, 4, 6, 8, and etc. And then we will be able, when we got the midterm as below, we will be able to write in canonical SOP. So what is canonical SOP? So as I said earlier, SOP is sum of product, and canonical is the state where we write all the inputs in the equation. So as you can see, as you know that there are 4 inputs, so we will write all 4 inputs in the equation. So by getting all the midterm from the notation, we'll be able to write the SOP as below. So f of A, B, C, and D is equal to M0 plus M2 plus M4, etc. So M0 is what? M0 is not A and not B and not C and not D, plus M2, which is, you can refer to the table. So this is how you write the canonical SOP. Alright, let's get to the next one. Next one is the max term. So it's almost the same as the midterm, with a slight difference where the max term is written as a summation. So A plus B plus C and plus D. And the notation for the max term is capital M, uppercase M. So it's still the same from M0 up until M15. And the output is still the same as we get from the truth table. So there are slight difference aside from the written in summation. Notice that when the input is 0, the max term or the term is written as D, like A plus B plus C plus D. And when the input is 1, we have a bar above it. So when the input is 0, 0, 0, 1, the max term will be A plus B plus C plus not D. and it goes up until the final term. For the final term, which is input 1 1 1 1, we will have not A plus not B plus not C plus not D, and that is the M15. So how do we group the max term together? Max term is written as POS, which is product of sum. So the max term is written as in summation, so we will group that as product. And then we only take the max term with the output of 0 as opposed to the minterm. When minterm, we take the output 1, and the max term will take the output 0. So there are around 1, 2, 3, 4, 5, 6, 7. 7 outputs of 0. So there are 7 max term. So this is how you write it. So f of A, B, C, and D is the product. This is the symbol of product of M 1, 3, 5, 7, 12, 13, and 15. So this is how you write the max term. Only take the output of 0. And then from the max term, we will be able to write the equation in POS, which is product of sum, and written as below. So this is the POS. F of A, B, C, and D is equal to the product of A plus B plus C plus not D times etc. etc. So you can refer to the table to identify what is M1, what is M3, and you put it in the equation below, which is POS, as the max term is in summation, so we just times them all together. The next aspect that we will discuss is the K-map and logic circuit. So for the K-map, it's written as below. So for this is the AB 0 0 0 1 1 1 and 1 0. Notice that we will put 1 1 first before 1 0. And for the CD is 0 0 0 1 1 1 1 0. So for the K-map, we will group them as 2s or 4, whichever the larger group that we can get. So if we group them together, we will get this. So this one is a group of 4, the bottom one is the group of 4, and here is also is a group of 2. So what can we do with this information? From this information, we will be able to derive a Boolean equation. So looking at 1 1, we will look at what is the similar or not changing aspect from the combination of A, B, C, and D. So as you can see, it goes below from the top to the second one. The A is 0 and 0, so A is not changing. But B, from 0, it goes to 1, so B is changing, so we will not take any B. And for the C and D, because it's the same column, it is not changing, so we also take C and D. But notice that A, C, and D, although they are not changing, they are input of 0. So we will write them as not A times not C times not D. And using the same logic, we will also derive equation for the bottom one. So the A and B will not be changing as it goes straight from horizontally. And the C and D, because it goes from all the way from left to right, all of it changes. So we will not take any C and D, we will only take A and B. But notice that B, although it's not changing, is 0. So it will be A and not B. And if you use the same logic for the right group, we will get the equation as below. Alright, I'll continue with the second part later.